So, is the PPT visible? I hope this is
Yes,
visible.
ma'am.
Yeah. So, coming to our unit 5. So, in our unit 5, we have the RTOS, real-time operating system, which is made of. So, this RTOS is made of. These are the topics that we have in our unit 5. I think we have completed I have given you introduction, isn't it? Comparison between desktop and real-time operating system is also over, right? Till which topic we completed? Do you remember? Where did we stop our last class? Can any of you tell me? Where we stopped our last class? Somebody kindly respond. Where did we stop our last class? Yes, students. Am I audible to you? Am I audible?
Yes, madam.
Okay. So you kindly tell me where we stopped our last class so that I can proceed further. Did we complete the introduction part? Did we start unit 5? Isn't we started, right? I think up to kernel we completed, if I'm not wrong. Isn't it? Do you have the habit of writing notes and all? Can any of you just confirm me? Can you just confirm and tell me till which topic we completed? Yes, students, kindly. Prithvi sir.
Yes, madam.
Yes, can you tell me where we stopped our last class? We completed up to
Up
kernel.
to desktop RTOS.
Yeah, this I think we completed. Difference between RTOS and I think this is
Up to
over.
here, madam.
Yes,
Up
sir.
to this. Up to here, madam.
I think
Kernel can start, madam.
I think I would have 1 second. I think I would have shown you this PPT. Sorry, this PDF file. 1 second. Yes, is this the PDF file that I showed you? So this PDF I actually explained you on. Yes. Yes. Tell me. Where did we stop?
Up to here, madam. This one.
Up to this.
Yes, madam.
So let me just refresh. 5 minutes I will refresh, then we will start. So our unit 5 deals with a real-time operating system. So we have the first topic, that is introduction, and then followed by that we have the desktop OS and the real-time or RTOS, and we have the next topic as task management, task scheduling, race condition, priority inversion, interrupt service register and scheduling, and inter-task communication. So these are the topics. I think, from here, it is task management, scheduling, interrupt service request, inter-task communication are all the part of the work done by the kernel. And of course, race condition is an undesirable condition, of course, and also this priority inversion is also an undesirable condition. Now, you have to know what is actually meant by RTOS, or the real-time operating system. You know, operating system is said to be a software, or sorry, it's a program, and it is the one that will run as soon as you turn on your system. So only because of the operating system, you find that when you turn on your system, it is asking you to enter your username and the password for your system, and only that through that we can enter into your system, and you can able to perform any application, whether you want to open a Word or an Excel, or you want to work with any software, anything it is run, then it is basic thing, basic program that runs behind is nothing but your operating system, and date, time, everything is getting updated by itself, isn't it? It's all because of the set of programs which is going to run as soon as you power on your system, and that program is said to be called as the operating system. And some of the main functions are said to be synchronization, interrupt handling, input output handling, communication, timer, count, clock management, memory management, and all that. So the even though you have different parts, the kernel is said to be the heart or the brain of your OS. And this OS, when you have the output with respect to time, you call it as the real-time OS. So there are two different types of, and you find your embedded system requires all the input as well as the output as function of time. So we say that this RTOS is also said to be, being used in large embedded systems, and we have two different hard system and soft system. So mainly we say those systems which cannot tolerate even a small delay is said to be called as the hard embedded or a hard real-time operating system, and the ones that can have small tolerance is said to be firm real-time system. And finally, soft real-time operating system is the one where even a delay will not have any change in the even the final output. So difference, you find the real-time operating system is said to be having deterministic output. It has an efficient task handling capability, and it has preemptive kernel. Priority inversion is not available, and it is useful in several embedded applications. Deterministic in the sense that it can able to fix a time. You can able to relate all your output with respect to time, and scheduling also, you can able to schedule the task based on the priority levels. And preemptive kernel means that is they are said to be time bound with the limited usage of all components, or with efficient usage of all components. Priority inversion is a problem actually which need to be avoided, and RTOS follows a mechanism through which priority inversion problem is actually avoided. So we are going to learn about this kernel. So this is the architecture of RTOS, where you have the kernel as the central unit. Along with that, we have the input-output system, file system, device drivers, networking protocols, debugging facility, and other components. So kernel, when I talk about kernel is said to be the heart, or it is going to act as the interface layer between hardware and the application program. Say for example, in order to make the computer to do any task, actually we have the hardware, which is the motherboard. But on the top of the motherboard, we are writing codes. Okay. But what is that which converts or which correlates or which makes which acts as a bridge between this hardware as well as the program? That is the kernel. So kernel is said to be a layer between the hardware and the application. And there are different types of kernels. One is the monolithic single program kernel. Next one is micro and hybrid. Finally, exokernel. Even you have nano kernels. Each one has its own advantages and disadvantages. So after this, what we are going to learn is all going to relate with the kernel, which has different services. The different services are task management, synchronization, memory management, timer management, interrupt handling, and the device input output management. Yes, did we complete this one, ma'am? Do you remember?
No, madam. No.
Okay.
No, madam.
I think up to this we have completed. So today we will start with the first function, that is the task management service provided by the kernel. So when I say task is nothing but an when I say in a real-time operating system, with the application will be divided into small different units. Okay. So these units or this small program, when combined together, which makes a big one, the small unit you call it as the task, and it is the basic unit of execution. And when I say a task, it involves So actually, like I can correlate this task as say you are asked to write an examination. So when you are asked to appear for an examination or to have to write an examination, it is not that only you write the exam. You have to, I have to prepare the question paper. I have to give it to you. You have to get it. You only after getting you can able to write, and when the time comes after 3 hours, I will get the paper from you. Only then the examination is considered that you have you have taken the examination. Likewise, the examination, writing examination is a big application, but writing that part is divided into small units like preparation of question paper, uploading of question paper, dispatching of question paper, receiving of question paper, execution, that is writing of answer, then submission of answer sheet. So that is divided into small units. So I can call the small unit as each one as a task. So when I tell you to write an exam, which is the big program, the big application, then I will fix 9 o'clock as the starting time of your exam. Then I will also fix 3 hours duration. Then I will fix 9 means 10, 11, 12. 12 is the ending time. Likewise, each task will be provided with 3 different times. One is the release time, next one is execution time, and the last one is dead time. Like this example, release time is refers to the point in which the task will be starting. So will start to execute, that is 9 o'clock. Deadline is said to be the point in time in which the task must be completed, that is 12 o'clock. And the in-between time, 3 hours duration, is the time required for you to write the exam. So that is the execution time. So this is how it goes. Okay. So we learned, now we will have to now look into the different states. So what is meant by a state? So, okay, let me tell you about task management before that. So, what is actually task? The very first service that is provided by kernel of RTAS is said to be called as task management. So, task management includes set of services that is used to allow application program developers to design the software design as a number of separate small units, chunks of software, each handling a distinct topic, a distinct goal, and sometimes its own real-time deadlines. Okay, so so the main unit of the task management is said to be called as task scheduling. So it includes control the execution of an application software task, can make them run in a very timely and a responsible manner. So this is what is meant by task management. And the very first part of the task management is said to be task object. Okay, so I want to tell you. Okay. Now moving on. So we learned what is the meaning of task management. First, the first part in making the task management is said to be knowing the task object. Then the work is task creation. Then it is said to be task scheduling. Only then you call that the entire process is said to be called as task management. So throughout we are making use of the word task. So I told you the meaning of the word task. So it is the basic unit of execution. And when I say task, it includes 3 different times: release time, deadline, as well as execution time. So, and again, this task, so you see here, task management includes creation, scheduling, and of course, deletion of a particular task. Now, looking into the states. What is actually meant by the state? I will move back to this. Is the PDF file visible, Mark?
Yes, madam. Visible, madam.
So these are the different states. What actually is meant by a state? State correspond to the the current working condition of a particular task. Okay, say there are different states involved in a task. Okay, so now we have the state we can able to see this diagram which illustrates the task states. So we have the state called as new, ready, running, terminate, and wait. So these, what is given in the inside the round, oval round, is said to be the names of the different states. So when I call the task as in state called as new, when the operating system is aware of the existence of this task, but the task is not allocated any priority level, and the content is not also included in the list of schedulable tasks. You understood? Like just I want to conduct one examination for you. Okay, so that is the first idea that comes to my mind. So when I want to conduct examination for you, what should be done? First, I have to fix the time. I have to fix the date. Then I have to set the question paper. Only when these three things are done, I can release. I can tell you that you have examination at this particular time on the particular duration and all. Right? So that idea which I say, that dumb examination in my mind, I will say, I will think that some examination I want to conduct. So that idea, that is called as new state. It means if from the OS point of view, it means the OS will be aware that there is going to be a task, but the task will not be allocated any priority. Like there is no timetable formed. I don't know where to fix my subject. So that is called, I can say that as the priority. So the task will not be having any priority, and the content also will not be included. It means I can say that the content, one second. So that is said to be called as the new task. So in this case, the task will not be allocated with any priority. It means my date is not confirmed. So I cannot say after which exam I will have my exam, or after before whose exam I will have my exam. So that is called as schedule. For you, just with the example, I'm correlating and saying. So this is called as the state one, which is the new state. Now, the task which is initially, whenever a task is formed, it will be always in the state called as new. Now you understood the meaning of the state new? Did you understand?
Yes, madam.
Now we will move on. So once the task is fully ready, what is ready? It means there may be several tasks in a state. In the state, it means the attributes of the task and the resources required to run it must be available, so that it is placed in the state called as ready. What is meant by ready? Everything is ready. If I am ready with my question paper, if I am ready with the timetable, then I can say, and if the timetable is also informed to you. All these are some of the requirements for you to write the exam. First thing, I have to prepare the question paper, timetable, date, everything I have to fix. Once if all these are fixed, then I will release that to you so as to make you know. And once this all done, then I will be calling that as the ready state, because everything is ready. When your turn comes, you have to write, isn't it? So that is called as ready. So that means in an OS, there will be several tasks in the state. It means I can say that uh, like so many, like me, many other faculty also will be ready to conduct examination, isn't it? So when so many faculty are ready with the question paper, what will be done is some schedule, some timetable will be framed. So that is called as scheduling. Okay. So based on the schedule, even though all are ready with the question paper, who were getting the turn only that examination will be conducted. Okay, but anyway, if all the question paper are ready, then I call the state as the ready state. Okay, a task, when it is formed, it will be new state. Once it is ready with all the required resources, it will move from new to ready state. Now we'll see what happens with the running state. Running. So it is said to be, this is the task which has control of CPU. It will be the task which has the highest priority of the task which is ready to run. It's like my turn comes, what will be done? Look at this. So the task which is initially formed will be in new, and when it is ready, it will be put in the timetable. My subject, all the subjects will be listed out in the timetable, and when my day comes, you will be sent to write the exam. So writing part is similar to running the corresponding program using the computer, using the CPU. So that state is said to be called as the running state. Okay, so all these we have seen. Now we'll look into the terminated state. Okay, now this state is said to be the one. 1 second. Hello. So this state is said to be called as terminated state. It's the state in which the OS, it means that the OS has not as yet been made aware of the existence of task, although it will be residing in the memory of the computer. It means I can say once my examination is over, okay, then what will be done? Once you have written the examination, after 3 hours, you will be moving it out, isn't it? So inside the timetable, in the schedule, the timetable schedule will have the subject, but since the work is completed, you have written the exam, the task will be put in the terminated state. Okay. Now, there are states called as waiting state in between here. So when this waiting state will appear, when this waiting state will appear is when an interrupt has occurred here. Say, for example, I can say somebody who is going, maybe some sports event is going to take place. In that case, if somebody comes with a requisition letter that if on the particular day he is going somewhere and he wants to conduct the exam earlier, then that is said to be called as interrupt. Normally, this process will take place. The task from new will move to ready, then from ready to run, and finally to terminate. But in some case, somebody, if they want to have the examination just before or after, that is called as interrupt. So what will happen during interrupt? During interrupt, the task which is running will be put in the waiting state. Okay, and the task which is interrupted will be put in the ready state and it will run. Okay, this is one condition during interrupt. The condition is the running state will be put into the ready state, and that interrupt which is required, which requires the CPU, will be moved to the running state. It's like a circle. The task which is running will move to ready, and the one that is ready as an interrupt will move to the running. And there are other possible cases also. The possible cases, sometimes when the OS wants to run a program, it will come to know that the task may require some more resources. So in such case, it will just move to waiting state and then it will go back to the ready state. This can be like if you are coming to the examination hall some 1 hour before or half an hour before, what will happen? Will you get the question paper? No, you will be, the question paper will become ready. I will think of making the question paper. They will think of making the question paper I will think of making the question paper. I will make the question paper ready, and when your turn comes, you will also be coming to write the exam. But when you come to write the exam, you are going to sit in the examination hall. But if only the time is 9, you will be allowed to write. But if it is before 9, you will be waiting for your time to come. So that is said to be called as waiting state. So you waiting means it has to wait in order to get the resources. Here the resource could be some time. Then it will move to ready, and then it will move to run, and finally on completion it will move to the terminated state. So did you understand? So these are the different states that correspond to a particular task. So when a task is said to be, whenever I say a task, a single task will undergo all these steps. 19 தான். ஆமா அதுதான். Yes ma, any doubt you have? You have any doubt? You have any doubt?
No, madam. No, madam. No, madam.
Is it clear? Okay, we'll move on to the next topic. So now, and to actually make a task, in order to create a task, or the content of a task, what should be the content of a task? So all the tasks, I'll move back. So it requires a task creation. Task creation is the first step in the making a task. So each of the tasks will be, that is the content of the task will be stored in a content unit or a memory unit called as task control block or TCB block. So the task uses this block to remember its content. So what in order to prepare the names, who are all going to write the exam, I will be making the name list, isn't it? Name list will include serial number, register number, roll number, mail ID, name, everything. Likewise, this task control block will include, or when I say task, it could be also examination. Examination implies subject name, subject code, your strength, department, semester, year, everything, date, time, everything. So when I say task, so the content of the task, so what all the task should contain will be available in the task control block. So they are nothing but their data structures. They will be available in the RAM unit, and it can only be accessed by the operating system. So the content of the task control block includes task ID, task state, task priority, task stack pointer, and task program counter. So task ID is an ID, unique ID given to the particular task. Task state, which state it is currently in, either it is new state or running state or ready state. Priority level, based on the priority. Say for example, I'm writing, if a timetable is made, highest priority will be given to the first day of exam, because it is the one that appears first as per the date. Then next priority will for the second exam, likewise. So fifth exam means on the based on date, if I prioritize, then fifth priority will be given to the fifth exam. And stack pointer is similar to the unit where the content is available, will be indicated in the stack pointer. And program counter will hold the address of the memory location from which this task program is decided. There. So once the task is created and once the content of task is all loaded in the task control block, then the next work is to make a schedule. How to make a schedule? Scheduler is the one, or dispatcher, they both are the same. They are the ones who are responsible for actually this scheduler, they keep track of the states of each task and selects from the different, from all the ones available, and that task which is ready to execute, and using the scheduler only, allocation of CPU will be made. So there are different methodologies adopted in scheduler. First one is the pole loop scheduling. So it is similar to sequentially determining if specific task requires time. So it can also work with interrupts. So like what will happen is it will go one after the other. Like there are 5 persons in a classroom, or some 5 persons are there, and I want to just to interact with these 5 students. Just I will allocate 5 minutes for each of them. Whether you like or not, I will be spending 5 minutes with you. So first person, first five, second 5 minutes, like that it goes. So wait for some time and do something, and again it goes to each and every person based on some order. So if interrupt is occurring, then it will service the interrupt and it will move back to the specified time. Then we have the round robin method, which is sequences from one task to another. Each task will be allocated some time. Then hybrid one, which can be non-preemptive or it can be preemptive. So in the hybrid system, it is going to be very much sensitive to interrupts, whereas a round robin will work in background, and it could also be interrupt driven, where system will continuously wait for interrupts. Then again, there are two different types of scheduling. One is the non-preemptive scheduling or cooperative multitasking. The second one is the preemptive scheduling or priority multitasking. So what is actually non-preemptive scheduling? It means higher priority task will be executed for some time. Then the control will be moved. Then it relinquishes control and re-enters the ready state. Like this is non-preemptive scheduling. So when the task one, when task one is performing, only when the task one completes its work, the priority will be given to the next task, which is task two. And when task 2 completes, only task 3 will be given chance for using CPU, and then task 4 will be given chance based on the priority. Okay. Whereas in this case, see, task 1 first is taking control of CPU. Then task 2 comes, and task 2 is not fully complete. We look at this. Task 2 is not fully, task 1 is completed, but see, task 2 is not complete. But if a request comes from task 3, which has more priority than the task 2, immediately the CPU control will be given to the highest priority of the included task, which means it will be preempted and then it goes to task 4. So this is said to be preemptive scheduling. Then a dispatcher includes, it gives control of the CPU to the task which is selected by the scheduler by performing content switching and changes the flow of execution. So now we will look into this task scheduling in detail. So this is the brief overview of task scheduling. So can you able to see the PPT now?
Yes, madam.
So when I talk about your task management, it includes first the meaning of task, creation of task object, and then the different types and the different states in the task, as well as the task object control block, and then task scheduling, which is the scheduler and the dispatcher. So scheduler is the one who gives the schedule of which task to be performed first or which task to be performed later and all that. Dispatcher is nothing but the one who does implements. Okay. Say our university, somebody will be there to put the timetable. But who is going to do the invigilation? The corresponding faculty. Likewise, dispatcher will keep track of the scheduled task and it will allocate the CPU to the task which is given as per the schedule. Right? So here scheduling is very important because it is the one which is going to decide how to allocate the CPU to a particular task. So scheduling is actually a very important concept in our real-time operating system, and it is going to decide the CPU utilization because it is the one scheduler which is going to allocate a particular task with the CPU, so that the CPU utilization is always a main concern. So the scheduler will see that the CPU is utilized to the fullest extent possible, and also the number of process that is completed per unit time will also be uh, more. It means using the same resource, always the scheduler will see that the utilization of these resources is done in an efficient way. Turnaround time is also minimum, such that the time interval between submission and completion is always lesser. Waiting time is also said to be lesser. Response time should also be faster, and fairness. Fairness means equal CPU time to all thread. The other name of task is thread. So whenever a scheduler is giving a schedule, it will also see that all the threads are given equal equal control of CPU, so that it completes the task that is allocated. So uh, so I can say task scheduling is part of the kernel service, and it will decide which task which task has to run soon after the completion of a current task. So each task will be assigned some priority level based on its importance. Sometimes the priority is also said to be application specific. The scheduling will be done automatically. So sometimes manual scheduling also will be done. Most of the RTOS, real-time operating system, makes use of priority-based preemptive scheduling. So it means higher priority task that is ready to run will always be given the highest priority for using the CPU. So preemptive scheduling is used when a process switches from running state to ready state, or from waiting state to ready state. It means the resources are allocated to the process for a limited amount of time and will be taken away, and the process will be again placed in the ready queue. And if that process still has CPU time, which requires CPU usage time still required. So I can say that under preemptive scheduling, uh, that is the CPU will be given chance for each of the tasks with some particular time. So some time duration will be fixed. Based on the time, each task will be given chance to use the CPU. And even if the task is not completed within the time, the task will move from running to ready state, and it will wait, and again when the turn comes, it will complete the task. Okay, some of the algorithms based on preemptive scheduling are listed out: round robin, shortest remaining time first, priority, preemptive versions, everything. Non-preemptive scheduling is used when a process terminates or a process switches from running to waiting state. That is, once the resources are allocated to the process, that is the task, will hold the CPU till it completes the task or it goes to the waiting state. So in case of non-preemptive scheduling, it does not interrupt the process running a CPU in the middle of the execution, but instead it will wait till the process completes its CPU usage time, and only then it will be allocated to the CPU for another task. So that is the two different methods of scheduling, and most of our real-time operating system makes use of preemptive scheduling. It's because if one task is given the full usage of CPU, sometimes there can be a chance where even the highest priority task also will not be given the chance to complete the task. So that is not, an advisable one. So most of the RTOS for embedded system makes use of preemptive scheduling. So actually, why this scheduling is necessary? It's because more information about the task will be known in terms of number of tasks, resources that is required, the time required to execute a task, as well as the deadline required by a task will all be known. And better, you can able to even design a better deterministic scheduling algorithm using the different known parameters and the different approaches. So we have different algorithms. So we have some different algorithms. First out, round robin with the priority scheduling, shortest job, fixed priority, preemptive multitasking scheduling are the different algorithms. But whatever be the algorithm, each of the algorithms are going to be based on these three different approaches. The different approaches, that is, there are three different approaches used. One is clock driven scheduling approach, weighted round robin scheduling approach, and priority scheduling approach. So what is actually clock driven scheduling? So in clock driven scheduling approach, all parameters about the job will be known in advance. Schedule can be computed offline or at some regular time intervals. Minimum runtime overhead will be there. There is not a suitable method of scheduling because it is required to know about the time required for a job, which is sometimes not possible. Next is the weighted round robin. Here, all the tasks that is scheduled will be of the form first in, first out. Each time will be allocated to a particular task based on its weightage, based on its usage, and or based on its importance. And uh, here it is not going to be suitable for precedence based jobs. That is, some jobs may require some data from the previous job. Like for example, if I have to compute some digital operation and with the real time data, how it is possible? Even though my digital operation operation done, operation related device or the corresponding circuit is free, only when I have an A to D converter to convert my analog or my real data into digital is available, only the next process can be done. So such type, if it is there, then you cannot have the weighted round robin methodology. Then the next is that to be priority scheduling. Here, some priority levels will be allocated to each task, and the priorities can be static, means when the schedule is made itself, some level will be fixed. It can be dynamic also based on the runtime. So priority based kernels of two types, they are non-preemptive and preemptive, as I told you earlier. All this we have seen earlier. Next we have the kindly mute yourself. Vivek, kindly mute yourself. Vivek, are you there? Vivek, we kindly mute. Okay. So is my PPT visible, Ma? Is the PPT visible to you all?
Yes, madam.
Then, as I told you, the dispatcher is the one which uh, actually gives control of the CPU to the task which is prioritized based on the scheduler. So, so it has the content switch. Through content switch only it does this operation. Actually, what is this content switch? The other names of content switch is the task switch or process switch. So whenever the scheduler switches from one task to the other one, maybe the task, it may switch from one task to the other one when the particular task is completed and it exits from the scheduler, or sometimes based on the priority level, some immediate task may require the usage of CPU. In that case, when an interrupt has occurred also, there can be requirement for switching from one task to the other. So in all these cases, the dispatcher will actually actually see to the content is switched. It means the control of CPU is moved to the task which is scheduled as per the scheduler. So actually, what is the meaning of this content switch? It means when I say task, the task will have its own content. It means the state of CPU registers required for task running. When the task is running, its content will be highly changing. The content of the task will be stored in a process descriptor table. So in order to store all these tasks which is running, and when the task moves, or when there is switching of the CPU control from one task to the other, content switch through, or the dispatcher through content switch actually does this operation. What operation is actually doing is, it will save the content of the current process and it will load the content of the new process. If the page table, if have page table, then it will update the page table entries. It will flush out those entries that belong to the old process. Not required entries will be just flushed out, and then this is what is meant by content switch, which will be done by the dispatcher. When this is done, then the processes control of CPU will be given to the new task, which is actually scheduled by the scheduler. And then moving on to the different scheduling algorithms, we are not going to be in depth into this. So we have the first in, first out, round robin scheduling, shortest job first, priority, fixed, preemptive, multitasking scheduling. So first in, first out, like it's a simplest scheduling method. All the tasks will be in a queue. The one that is given entered first will be given a chance to use the CPU. So it may require, or it may result in a problem called as starvation, which means sometimes a process which will require an immediate attention of your CPU may not be given because it has entered the queue at the last. So that is said to be called as starvation. And then there also can be a problem when any process will be continuously using the resource. And when they continuously use the CPU for a long time, those processes, even though they are immediate, they may not be given even a chance to complete this task. Then that is called as starvation. Shortage of food is called as starvation. Likewise, a task which is not given the chance, shortage of CPU usage is also called as starvation from the context of RTOS. So that is first in, first out. Second is the round robin scheduling. So what will be done is the scheduler will be assigning a fixed time unit per process and cycles to them. So this you can able to see task 3 happens after 2 tasks, task 2, task 1. So this green color is task 2. See, task 2 happens after 2 tasks and task 1 happens after 1, 2, 3, 4, 5 tasks. So some fixed time delay will be there between each of the tasks and they will be following that corresponding time delay. Okay. So it has the fastest average response time, waiting time, and the waiting time is dependent on the not on the number of process and not on the average process length. Sometimes because of high waiting time, deadlines will also be difficult for the task to meet. But here in this case, starvation will never occur because no priority is given. Order of time unit is based on the process of arrival, similar to first come, first serve allocation method. Then shortest stop first algorithm. So see here, here what will happen is the scheduler will arrange the process with the least estimated processing time remaining the first to the next one in the queue, so that the one that requires less processing time will be given the chance so that it gets completed. Okay, so if the shortest process arrives during another process execution, then the currently running process will be interrupted. Then it divides the process into two separate blocks. So that is shortest job. The one that has the shortest completion time will be given the first chance for completing the task. So here the waiting time and the response time increases because as the process computation requirement also increases. Actually, this is mainly meant to improve the throughput of the system. And here no particular attention is given to deadline, and here also there is possibility of starvation. And then priority preemptive scheduling. So here some priority level will be assigned to each task based on the priority level. Even a task when it is running, when a higher priority task arrives and it is ready to run, the lower priority task which is currently running will be put up into the waiting state. That will be put up in the start ready state, and the one which has the highest priority will be given for running the task. So that is all about preemptive scheduling. So next class, we will look into synchronization, intertask communication, and other important left out topics, that is race condition and priority inversion, and finally the semaphores. So with that, we will be completing our unit 5. Okay. So let me answer the attendance. If you open the attendance. Second mark. Answer your attendance form. Today's date 29 of 7. Is the attendance visible to you all?
Yes, madam.
Okay. Ajay Sundar,
Present, ma'am.
Anil Arya,
Present, ma'am.
Aravindan,
Present, ma'am.
Babu,
Present, ma'am.
Balamurugan, Dineshya,
Yes, ma'am.
Dinesh P,
Yes, ma'am.
Ganesh Mani, Karthikeyan, yes. Yes, Karthikeyan. Kumar,
Yes, ma'am.
Mahalakshmi, Mahalakshmi, Manikandan, yes.
Present, ma'am. Present, ma'am.
Manikandan, yes.
Present, ma'am.
Manoranjan Sapu,
Yes, ma'am.
Naga Soundarya,
Yes, ma'am.
or Pandian,
Present, ma'am.
Paneerselvam, Paneerselvam, Koteswara Rao,
Yes, madam.
Samuel Raj,
Yes, madam.
Sangari Devi,
Present, ma'am.
Sanjeev Kumar, Sankaranarayanan,
Ma'am, yes, ma'am.
Sir C.V. Raman, Sir C.V. Raman, Satyamurthy,
Madam, Satyamurthy sir's mic problem like that, he messaged me, madam.
okay, sir. Selva Ayappan,
Yes, madam.
Sudarvanan, Sudarvanan, absent. Vivek B,
Present, ma'am.
Vivek,
Present.
okay. Jagadishan,
Present, ma'am.
Dayalan,
Present, ma'am.
and Rajendran.
Present, ma'am.
So today's absentees are Balamurugan is there. Balamurugan sir, I could see you in the participant list. Kindly unmute. Okay. Balamurugan is there. Karthikeyan, yes.
மேம் நான் செவன்த் செம் மேம் பாலமுருகன் அவர் இல்ல மேம்
Sorry, sir. Karthikeyan, yes, absent. Mahalakshmi, absent. Paneerselvam, Koteswara Rao, Sanjeev Kumar, Sir C.V. Raman, Sudarvanan, and Vikram are the absentees for today. So we will complete Unit 5 probably in the next week. Maybe probably in the next class. So next class, we